Okay, so let's pick back up section 5.7. And we're going to check for perfect square trinomials. So let's just go straight into our next example. Let's look at this example right here. 25x squared minus 70x plus 49. Okay, remember I told you when your eyes first hits that problem, what's the first thing we look for? GCF. This doesn't have one. There's nothing that goes into 25, 70, and 49. And there's no x in every term. So there's no GCF, so that's out. Next, it's a trinomial, so we don't have to try grouping. All right, so the next thing I ask myself, is it the easy case? No, because of the 25. Now, I've got two options left for trinomials. Either Brew method or perfect square trinomial. I always check for perfect square trinomial first because if it is a perfect square trinomial, it's easier than the Brew method. So is this a perfect square trinomial? Well, what has to happen for this to be a perfect square trinomial? Two things. First, this has to be a perfect square trinomial. Can you take something times itself and get 25x squared? Yes. 5x and 5x. Now, can I multiply two things together and get 49, positive 49? Yes. 7 times 7. Let me say again, if this were a negative 49, it would not be a perfect square trinomial, and then I would move on to the Brew method. Okay, so we're okay with the first part. Now what do we have to do? Multiply these two together in our head, 35x, and double it to get 70x. So yes, this is a perfect square trinomial. So the 25x squared breaks up 5x and 5x. The positive 49 breaks 7 is 7 and 7. But this says the signs are the same, both negative now. So it's going to be 5x minus 7 times 5x minus 7. Or you could write it 5x minus 7 quantity squared. Okay? And let me say one other thing here. Because again, students ask this. They'll say, well, Mr. Rainer, if the Brew method works all of these, I mean, I get that the perfect square trinomial is a little quicker, but I'd rather not learn this method. I'd rather just go straight to the Brew method. The problem with that is this. If you do the Brew method on this, you will get the same answer. But look at what you have to do in the Brew method. You have to multiply 25 times 49. Well, that's huge. 25 times 49, and then you have to break that number down and find what works to do the Brew method. So that's the reason I strongly encourage you, before you jump on the Brew method, that you ask yourself, is it a perfect square trinomial, before you resort to that Brew method. So GCF, easy. This is for trinomials. GCF, easy case, perfect square trinomial, and then Brew method. Okay, let's do another one. Let's see. 4x squared plus 28x plus 49. Okay. First thing I look at is ask myself, does it have a GCF? No. Next, is this the easy case? No. Next, is it a perfect square trinomial? And you say, yes. Well, I don't know yet. I haven't checked it. You say, well, that's a perfect square and that's a perfect square. That's not enough. You have to check two things. So first, is this a perfect square? Sure. 2x times 2x. Is this a perfect square? Yes. 7 times 7 is plus 49. But you have to check one other thing. multiply these two together in your head, which is 14x, and if you double the 14, you don't double the x, you just double the number in front of the x. If you double the 14, do you get 28? Yes. So this is a perfect square trinomial. So this will be 2x and 2x, 7 and 7, signs are the same, both plus. Now, one common question sometimes students ask is this: Mr. Randall, what if I multiply these two together and double it and I don't get this? For instance, suppose this right here had been an 11. So if you double 14, do you get 11? No. So what that means is, it means it's not a perfect square trinomial. And you say, well, then it's non-factorable. No, because if it's not a perfect square trinomial, you have one other method to try, and that's BRU. So if either one of these two things that I'm checking for fails, I still have to go on and try the BRU method before I can say non-factorable. All right, and again, I can write this 2x plus 7, 2x plus 7, or 2x plus 7 squared. And by the way, just to go back to something that was on your test 1, or not the test 1, in section, this was section 5.4, I think. I showed you how to multiply this out without doing the FOIL method. You remember me saying when you square a bi, you get a tri? And so what we do is I said square the first one. 2x times 2x is 4x squared. Square the last one. 7 times 7 is plus 49. And then you multiply these two together, which is 14x, and you double it, which is 28x, which is exactly where we started. That's why you have to do that second part to see if this is a perfect square trinomial. So really what we're doing here is we're just going backwards from something that I showed you earlier. Okay, let's do 2 more examples here. Give me some more paper right quick. Okay, so okay, first, look for a GCF. This doesn't have one. Next, see if this is the easy case. It is because of the 1 right here. So, this is the easy case, or it's non-factorable. So let's see. X squared breaks up x times x. Signs are the same, both plus. This is the easy case. We did this at the very beginning of section 5.6. Now I need 2 numbers that multiply to give me 25, that adds to give me 10, which is 5 and 5. You say, well, wait a minute, Mr. Randall, that's a perfect square trinomial. It was. It is. You say, well, we didn't check for it. That's because it was an easy case, perfect square trinomial. That's why I always say check the easy case before you do the perfect square trinomial. Because if it's an easy case, perfect square trinomial, it's quicker to do the easy case first. But it was still a perfect square trinomial. Okay? Let's do one more here. All right, so let's look at this one. Just a second. Okay, so let's look for a GCF. There's not one. I'll just put an X, meaning no. Is this the easy case? No, because of the 4. Is it a perfect square trinomial? Well, let's see. This is 2x, 2x. This is 3 and 3. That's a plus. Now, if I multiply these two together, I get 6x. If I double it, I get 12. Yes, that's a perfect square trinomial. So this would factor as 2x and 2x, 3 and 3. Signs are the same, both negative. Or you could write it 2x minus 3 squared. Okay, let me look at one more here, because there's one more thing I want to show you on this. So let's look at this one. 4x squared minus 15x plus 9. And let me say again, remember, these can have GCFs. If they do, you factor the GCFs out first, and then see if what you have left will factor again. All right, so let's see, 4x squared minus 15x plus 9. Okay, let's look at this one. First, look for a GCF. No. Next, easy case. No. Next, is it a perfect square trinomial? Well, let's see. Is this a perfect square? Yes. 2x and 2x. Is this a perfect square? Yes. 3 times 3 is plus 9. If I multiply these two together, I get 6x. If I double it, I do not get 15x. So no, this is not a perfect square trinomial. Now, that does not mean that the problem is prime. What that means is, it means that I have one other method to check. Now, it may be prime, but I can't call it prime until I use my last method, which is the Brew method. Now, how do we do the Brew method? Going to do this again. So come to the side, take the number in front, bring it down here with the 9 and multiply them. So leave everything else the same. So 4 times the number on the end, which is 36. Okay, now I want to factor this. Now let me remind you something about this. If this does not factor, then the problem is prime. If this does factor, this is not my answer. You still have to do the Brew method. All right, so let's look at this. So let's see. X squared, x times x, signs are the same, both negative. I need two numbers. When you multiply them, you get 36. Now, it may help you, if you can't roll those numbers around in your head, come to the side and write out the combinations of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So, what are we looking for here? We're looking for two numbers that adds together to give me 15. Well, clearly 3 and 12 are my two numbers. So, 3 here. Doesn't matter which one goes where because the signs are the same. Now, we're not finished. Matter of fact, just started. B, under the bottom of these two, put what you divided by, which was the 4. Now we got to divide by it. R stands for reduce. 3/4 does not reduce, but 12/4 reduces to 3/1, or I'll just write it 3. And then U stands for up. Bring this number up. There's no number over here to bring up other than an understood 1. So this would be 4x minus 3, x minus 3. So that is how this problem right here factors. So was this a perfect square trinomial? No. But did it factor? Yes, it still factored. Can I check this? Absolutely. I can check this by the FOIL method. So this closes out, I'm not done with factoring, but this closes out factoring trinomials. So in closing on trinomials, let me say this one more time, and I'm going to give this to you in a note in just a minute, or in just a little while, a couple of videos from now. So when I'm factoring a trinomial, when I look at that thing, the first thing I ask myself is, does it have a GCF? If it has one, factor it out. If you factor it out, ask yourself, does what I have left factor again. Because remember, the instructions now doesn't say factor, it says factor completely. And so I'll try to factor it completely. All right, then if it doesn't have a GCF, or if it does, factor it out. The next thing you ask yourself is it the easy case? If it's the easy case, factor it. Then the next thing you ask yourself is it a perfect square trinomial? But in order to do that, you have to know the two things you need to know to recognize perfect square trinomials. And then if it's not a perfect square trinomial, the last question you ask yourself is, can I factor it by the Brew method? So that is how you factor trinomials. Okay, to complete this section, we're still going to be in 5.7. That was 5.7 part 2. We're probably going to have 2 more videos on 5.7. But what we're going to do now to end up in section 5.7 is we're going to look at factoring binomials. Now, if you'll think, all the problems we've done so far, GCF, a binomial could have a GCF. But will grouping work on a binomial? No. Will the easy case work on the binomial? No. Will perfect square trinomial work on the on a binomial? No. Will the Brew method work on factoring a binomial? No. So none of the methods other than GCF, none of the other methods that we've covered is applicable to factoring binomials. So, do all binomials factor? How do we factor a binomial? And if it does factor, how can we tell? So in the next couple of videos, we will be talking about what to look for and how to factor binomials. Now, grouping and easy case and perfect square trinomial and Brew method, you can push every bit of that to the side. None of that applies to binomials. So we're going to reboot, we're going to reset, and what we're going to do in the next video is how do we factor binomials if they are factorable. So we're going to reset and talk about something completely different as far as technique. Now we're still talking about factoring. We're still looking for 2 things that multiply together to give you that. But how we factor binomials is a completely different thought process than how we do trinomials and 4 terms. So this concludes our part 2 video in section 5.7. Next video, section 5.7 part 3 video, factoring binomials.